web address that you can take in account. I will show you once again a bit later. But this address is especially done for TGT, so that allow you, Ibrahim, to give to all the practitioners who can use that, and then I will show you that will help all the practitioners to fit all the type of LCS lenses, and then TGT will receive directly the prescription. I will show you that later. So just a few words about my team. So LCS is a contact lens manufacturer based in France. And I have a team, a large team. Well, we are a bit less than 50 people. I have a lot of optometrists. We have around 15 optometrists altogether with the professional services. And I am personally also an optometrist. I have been graduated at the University of Paris, specialized in the contact lens fitting. And as a practitioner, I have also developed a lot of design. And so we master everything. We designing, we manufacture, and we are also advising all the practitioners. My main goal is to have, to give good options to all the practitioners in order to help them to fit any patient. So all the manufacturing facilities are in France. So this is France. So we are in the northwest of France, near Paris, just 200 kilometers away of Paris. And we have developed a large range of specialty lenses. I can say that we have the largest range of specialty lenses in the world, because we have all different RGP designs, different ortho-K designs, scleral designs, but also hybrid design. There are just 2 manufacturers of hybrids in the world. We are one of these manufacturers. So I have invented a way to manufacture a hybrid material, and we manufacture the hybrid material and the hybrid lens at the end. So the goal of that is to be sure that if you have any need, normally we will have an answer in the specialty lenses. We do not manufacture any disposable lenses. We just manufacture specialty lenses. So let's talk a bit more specifically on the, I just wish to check something. Okay, let's talk about a bit more about our scleral lens, so which is called AKS. The scleral lens indications are linked to the state of the cornea. So you have 2 main indications. If you can have patients with corneal irregularities. So in this type of corneal disorders, you can find, of course, keratoconus, PMD, corneal graft. I mean, all those type of corneal shape which affect the quality of the vision because of quality of shape of the cornea. So using the scleral lens for high shape disorders is a very good option. We have also another interesting indication, which is the indication for the severe dry eye syndromes. So all the corneal surface disorders linked to the dry eyes. So that is also a very interesting indications, because we can, in that case, not only compensate the optical disorder, but also we can afford a much better life for the patient, because we can we can solve the problem of discomfort or even pain. There are some patients who have severe dry eye syndromes and they have a severe pain. And when you insert a scleral lens, you stop the problem of the pain, and you give a much better life suddenly to these patients. And the last indication is to the patients where we did not manage to fit them in RGB or hybrid lenses. So you have different type of topography, sometimes from the small corneal disorders or an early keratoconus. And when you have an early keratoconus, most of the time it is better and easier for the practitioner, but also for the patient, to be fitted with soft or RGP lenses or hybrid lenses. But as soon as you have more advanced cases on the shape disorders, corneal shape disorders, it is much easier to fit with a scleral lens. So that is what we have developed with the AKS. We have developed a large range of parameters in order to allow the practitioners to solve and to answer to all the needs. So first of all, the parameters of the lens, you have the material. The material of the scleral lens is a high decay. This is the highest decay actually available in the world, because we have a decay of 211. So we call it the decay 200. So you can ask the scleral lens with that, with this high decay, or we can ask the scleral lens with the standard decay of 125, which is good enough for most of the needs. But for some cases, if you need to improve the transmissibility of oxygen, you can have this option to ask for a decay 200, which will increase the security of the fitting. You have a large range of diameter from 14.50 up to 17.50. This large range of diameter allow to normally fit most of the needs. But we have two standard diameter, which is the 15 and the 16.5. Our scleral lens is thin, so we have worked on the thickness of the scleral lens in order to make it thin, the thinnest as we can. So the thickness of the scleral lens for -3 is 200 microns, so 0.2 millimeters for the diameter of 15. I am quite proud about that, because when you do an optical section with the slit lamp, you can see how thin is the lens. I saw Ibrahim also showing you an OCT picture. You can also see how thin is the lens with the OCT picture. So, of course, that is very important, because that affects, at the end of the road, the quality of the oxygen transmissibility. So the thinner lens you have, the better oxygenation you have for the cornea. So, of course, that is very important. And despite this thin lens, we managed to have, there is no deformations. The lens still have a good shape, and so we managed to have a good visual acuity even with the thin lens. We have different SAG. We have 21 different SAG variations from 3,600 micron up to 5,600 microns by 100 micron step. And so normally with this large range of SAG, you normally can fit all the type of corneas, even from the flat ones, so the oblate corneas, up to the very prolate corneas. I never heard about any case that we did not manage to compensate. Sometimes that is hard work, but we manage anyway. And then concerning the powers, there is no limits. We can do all the powers from -40 up to +40, and with all the type of cylinders. So that means that we can do front toric lenses with very high cylinders with no limits. So from now on, do you have any question? Is that clear enough? Do I speak clear enough? Do you understand everything? No problem?
Très bien, merci.
Ah, okay. Thank you. To be able to fit the scleral lens, you need a trial set. Actually, there is no other precise way to fit any scleral lens without a trial set. Well, this is helpful, I mean, for practitioners. This is very helpful to have this trial set, because even if you need this trial set in order to define the right parameters of the final scleral lens, that is also a good way to show to the patient how comfortable is the lens. And that is useful in order to motivate the patient, because you have, as a practitioner, to present the option you're going to offer him. And when we talk about a large rigid lens, you can have some patient who can be scared about this large rigid lens. So when you have this trial set and you insert the first lens to a patient who have been in some trouble in the last few years, wearing RGPs, failing to wear any contact lenses because of discomfort. So when you have this opportunity to try directly one lens, you will see the patient very surprised about how comfortable is the lens. And so you will gain a very motivated patient, because suddenly he can realize that that can be the end of all the trouble of comfort, all the trouble of the visual disorders that this patient is suffering. And because we are talking about comfortable comfort at the insertion, but also during all the day long. This is also one of the advantage of the scleral lenses, even for the very advanced keratoconus, for example. When the patient is well fitted, he can wear the lens and then without any trouble with the dust all the day long. He can do all the activities, he can work, he can do sports without complaining with the dust. So now the goal of the presentation is to give you all the main line in order to be able to fit different type and all the type of corneas. So there's different advantages of the AKS. We worked in a way to develop the scleral lens in order to give a better life for the practitioner, to make the fitting easy. because I'm convicted that as a practitioner, we don't need to spend too much time in all the technical needs. We need to spend more time with the patient, talking with the patient, doing all the assessment, explaining to the patient. But if we can fit any lens, especially here a scleral lens, easily, that is one of the key of the success, and that is also very important because that gives you more time to spend explaining how to insert the lenses, how to handle the lenses to the patient. So this scleral lens is easy to fit because normally you insert one lens and you know that there will be no change of the power if you change the sag of the lens at the end with the other. And it's the same if you can change the diameter of the lens without changing the sag. Um, we have also a large range of geometries, especially asymmetrical geometries, asymmetrical designs, in order to compensate all the irregularities of the cornea. And the last point is the fact that the scleral lens LCS is very comfortable because of the thickness. It's a very thin lens and very comfortable. So as I told you, it's important to have in mind that when you change the diameter of the lens, that do not affect the value of the sagittal depths. Well, that do not affect the clearance you have in the center. So that means that if you have inserted a lens from the trial set with a total diameter of 16.50, you do your assessments behind the slit lamp and you see that, well, the lens is a bit too large, you 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 will be able to order the final lens with a smaller diameter, 16, and without changing any other parameters. So you can assess, you can do all your assessment at the slit lamp with the 16.50, even if you finish, you know that you finish with a diameter of 16. So that normally allow you to insert just one lens, do all your assessments in terms of clearance, diameter, and then you will be able to order the lens. Because the goal of a good scleral lens is to fit a lens with a clearance all around the cornea. So the goal of the good fitting is to avoid any touch on the cornea from limbus to limbus. So in order to do that, we have four different parts of the scleral lens. So you have four different parameters. The first main one is the sag for the sagittal depth, which is the total sagittal depth of the lens. So as I told you, we have 21 sag, so from 3,900 microns up to 5,600 microns. And then we have three other parameters. So the C for cornea, the L for limbus, and the S for sclera. So it's for LCS. So the same name of the lab, LCS, L for limbus. The main one that you're going most of the time to adjust when you need is the L for the limbus and the S for the scleral. We have also two types of toric design. We have a regular toric design. So we have a symmetrical toricity. So this is, well, all the lenses in the trial set with the diameter 16.5 are toric, and the 15 are spherical. I will talk a bit later about this slight difference. But in some cases, you will also need to have an asymmetrical toricity. So we can do that with the lens. I will show you how it works. So for the asymmetrical toricity, we call it ATD for asymmetrical toricity design. So this is IKS ATD. As I told you, that can be useful for some cases. For example, here, if you have a lens which is perfect, except that you have a loose area only on one quadrant, so we can solve it with an asymmetrical design. We can also manufacture microvolt, which is, of course, more than helpful for fitting a patient who have a pinguicular or pterygium. So this microvolt allow you to fit and those patients and allow you to avoid to have a compression like this photo here. If you have a pinguicular and you fit a scleral lens, you have this compression. Well, the compression on the pinguicular is not a big trouble that will not affect really the eye, but the problem is that give a red eye, so you begin to have.
Emmanuel? Okay. Emmanuel?
Is that okay? Okay, my mic was off. I just, okay.
Yes, I hear
you. Okay, can you hear me now?
Yes. I believe that.
Okay.
Explain from microvolts.
So these microvolts avoid this compression, and there's different grades. As you can see in this picture, there's 3 different grades. So if you have a small pinguicular, you can use just the grade 1, and that will sufficient in order to avoid any compression. The grade 1 create a volting on the microvolt of 190 microns. So that means that you have an elevation of 190 microns. The grade 2, you have 330 microns. Grade 3, you have almost 500 microns. We do not use, or very rarely, the grade 3, for being honest. So in some cases, like a quite advanced stage pterygium. But for being honest, we use most of the time only the grade 1 or grade 2. This is most of the time sufficient in order to have a good fitting. Well, now when you have a trial set, how do you fit the scleral lens? Well, as I told you, we developed the fitting in order to make the life of the practitioner easy. Okay, so you can use the lens in the trial set linked to the indication of the cornea you have in front of you. Because the indication define or give a good idea of the global sag of the eye of the patient. If you have a keratoconus, excepted if it is a very early stage of keratoconus, but if you have, I would say, a mid stage or grade 2, grade 3, normally we advise you, as you can see here, a medium, you're in a medium elevation state, so we advise you to insert a lens with a sag of 4,500 microns that you will find in the trial set. So you take this 4,500 microns sag in the trial set, and then you insert the lens in order to do your assessment. And you have also two type of colors in the trial set. So you have 16 lenses in blue colors and 14 lenses in blue colors and 10 lenses in green colors. The lenses in blue colors, the 14 lenses have a total diameter of 16.5, and those lenses in 16.5 diameter, they are all toric. They have a toricity of 5 degrees. The other 10 lenses have a diameter of 15 millimeter, and they are all spherical. So that means that with this trial set, you have 14 lenses which are torics. I'm talking about back toricity, the toricity on the sclera, and you have 10 spherical lenses in a smaller diameter. So the reason of why we have torics with the larger diameter 16.5 is because when you have a larger lens, you go more far away from the limbus. So when you go far away from the limbus, you have more toricity in most of the cases. This is linked by depression of the lids and also the insertion of the eye muscles, so that affect the toricity of the global eye. So that is the reason why it is really rare to have a large diameter 16.5 spherical. You have, but this is rare. In 10% you can find that. In the reverse, when you go closer to the limbus, you have more cases where you need a spherical fitting, a spherical lens, because you have most of the time, spherical sclera close to the limbus. I'm talking about ratio. So you have 50% of the patients who have a spherical sclera just after the limbus. So with this range of different SAG, normally you can begin to fit from the oblate corneas. So, for example, the post-refractive surgery or any oblate corneas, up to the very protrusion corneal transplant. So with a 5,100 microns. So changing the diameter and choosing the diameter is also linked to the size of the eye. You have some patients where it is limited, so that can affect your choice of diameter. So the 15 millimeter is mainly for the small cornea or the small eyes. And the standard one, 16.5, is the most used diameter. And so once again, those diameters are toric in the trial set. But you can order a 16.5 spherical if you need. I mean, that we can do. And it's the same. We can also manufacture a toric in 15 millimeter. So that is also possible. So when you have inserted a scleral lens from the trial set, then the next step is to assess the fitting. And the assessment is mainly, the goal is to check if you have a clearance in all the surface of the cornea, from limbus to limbus. So you have two ways to check that. I mean, the most common way is to insert fluorescein in the lens at the insertion, and then to check if you have any touch, any clear or any excess of clearance. So the quality of the fluorescein pattern will be sufficient in order to give you all the information. So you check the quality of the fluorescein in three different areas, four different areas: the central, the paracentral for the C. Here you can see here, and then the limbus, so close to the limbus, and then you have to check how the scleral lens is landing on the sclera. So on the sclera, you need to check if you have any compression or not. If you have a regular cornea, for example, which is the case for dry eye syndrome, you can have a regular cornea, a regular shape. Most of the time, you will be impressed by the fact that with the first insertion, you can have a perfect lens without changing any parameters. So you will just have to do the over refraction in order to be able to order the lens straight away. But in some cases, if you insert the lens from the trial set, you will find some specific disorders. So, for example, here on this picture on the top left, you have this touch, which is quite frank in the paracentral area of the cornea. So, of course, it is, well, you cannot leave a scleral lens with this touch, because if you leave a scleral lens with this type of touch, normally that will create a staining, correlation staining in this area. So, and then after few days, few weeks of wear, that can go up to an ulcer. So that is the reason that it is better, of course, to avoid such a touch. You can have also a small touch in almost the central. On the bottom right, you have this typical picture of a large touch at the limbus. So typically, if you have such a touch, you will have to do something in order to avoid that. So if you need to assess the lens, so once again, you need to assess in those four different areas: central, paracentral with the C, the limbus, and the sclera. And then you will have the possibility to adjust the lens with different index. So, well, first you can change the sag, the central relationship with the cornea, with changing the global sag of the lens. Then, if you have, for example, here in this drawing, a touch at the paracentral area, so you can avoid this touch with increasing the index of the C parameter. Increasing the index will increase the clearance only in this area of the C. Knowing that if you increase the index of a parameter C or L, that increase the central clearance of 30 microns. And we can change the index from -15 up to +15. That happens sometimes. We need to go up those extreme index, but most of the time you just change the index by 3. That means that, for example, on this picture on the bottom right, with the limbus. So you have this touch at the limbus, you see that. So you cannot leave the lens like that, but everything, if everything is okay, except this touch at the limbus, you will just have to order the lens with an L plus 3. L plus 3 will solve the problem of this contact in the center, at the limbus, sorry. And then another important point also is the fact that all the toric lens, the EKS toric, are engraved. You have two small lines, and those small lines are aligned with the flattest axis of the limbus at the sclera. So the flattest axis is aligned to the two marks here. And that's very important because this is a parameter that we will talk about a bit later, because that gives you the stabilization. So the stabilization value, that means that when you insert a lens in the patient, a toric lens, you will need to evaluate and to note what is the stabilization value of this toric lens in the eye of the patient, because that will then allow you to either order a front toric lens or to order an asymmetrical lens in order to solve a pinguicular compression, for example, or something like that. But we need this information of the stabilization of the lens. For the sclera, it's the same. You insert the lens and then you have to evaluate, knowing that the perfect fitting normally is without any compression of the bulbar conjunctiva. So it's easy, and it's done with the white light. For example, in this picture on the right, you have those two compression at 9 o'clock. Sorry, at 3 o'clock. At 3 o'clock, you have those two compression, and when you have such compression, then you begin to have a global red eye. So it's normally then easy to solve that. I will show you later how to do that, but so it's important to assess that and to solve that with a new lens, that with the right parameters, in order to have any disorders. So how to fit the lens? Once again, I'm going to show you first a simple case, because I like to start simple. That's very important. So if you have a case like that, you have just the topography showing that this is an obvious keratoconus with a more advanced case on the left eye. With the right eye, you have just a smaller refraction, and the left more advanced refraction, but a low vision. So in both, in those cases, you need to insert a lens and to choose a lens from the trial set. And as I told you earlier, if you look at the fitting in the trial set, you have a range of indication showing you that if it's a keratoconus, you take in the trial set the 4.5 millimeter SAC, so the 4,500 microns. You insert the lens, and then you evaluate, and if everything is okay in terms of clearance, you just do the refraction, and then you can directly prescribe the order the lens, just taking in account the over refraction. So that can be most of the time as easy as like that. I mean, there is no other point. So the assessment of the clearance is done in order to have at the insertion a clearance of 300 microns. But I'm talking about the clearance at the insertion, because we know that after 1 or 2 hours, there is a decrease of this clearance just because the lens is settling in the eye, and there is a slight compression of the bulbar conjunctiva, and this small compression decreases the global clearance of around 125 microns. This is what we know. So you know that between the time you do your observation at the insertion and at least 1 or 2 hours, you have a decrease of a global clearance of 150 microns around. And a perfect clearance at the end of the fitting is a clearance at a maximum of 250 microns. The optimal clearance is 150 or 200 microns. So this is the final goal. So that is the reason why at the insertion, if you have a clearance of 300 microns, that is fine, just because you know that this excessive clearance of 300 microns will decrease after 1 hour of wear. It will decrease down to 150 microns, which is a perfect clearance. Okay? And this assessment of clearance can be done with the OCT. Well, if you have the chance to have an OCT, that's perfect. But you do not need an OCT. You can do this assessment only with your slit lamp, and you do an optical cut. And with the optical cut, you can have quite a precise evaluation, because with the optical cut, you see the clearance, and then you have, you know, the thickness of the lens, which is around 200 microns. You know also the thickness of the cornea, except if the cornea is abnormally thin or thick, but a normal cornea is around, I would say, 520 microns. So when you do the comparison between the thickness of the scleral lens and the thickness of the cornea, that is sufficient to compare with the clearance. And most of the time, doing that, we can have a perfect idea of what is the clearance. Is you have a clearance of 100 microns, 200 microns, 300 microns. And easy to do, and this is sufficient in order to be precise enough. Before to see how to insert and remove the lens, do you have any question on the basic on how to fit the lens? No? No question? Okay.
One of the colleagues asked, can you hear me?
I just finish here with inserting and removing the lens.
Excuse me, Emmanuel. Can you hear me?
Yes, I hear you now.
One of the colleagues asked why you start with the toric lenses. I mean 16.50. Why start with this toric lenses?
Because in most of the cases, when you use a 16.5, the scleras are toric in most of the cases. So that is the reason why we advise to directly insert a toric lens when you use a 16.5. The reverse is rare. when you insert a 16.5 and finally, well, you need a spherical, it is rare. That happens, but that happens in 2 or 3%, something like that. So that is the reason.
Thank you. Thank you.
My pleasure. So handling the scleral lens is very important. I have seen that Ibrahim has already shown you how to insert the lens. Having small devices like the suction holder is very important. So the different type special suction holder to insert, the other ones to remove. We have also manufactured rings, as you can see here, small ring that can help some patients in order to allow them to insert the lens more easily. So such small devices can be important in the success of the fitting, because once again, such small devices can help to fit patients who have, for example, some problem with the hands, their fingers. I have seen some old people, they're happy with the scleral lens, but they have some trouble with handling because their hands are old hands. And so they manage to insert the lens only with a ring, as you can see here. So small things like that can be important in order to help you in the success. Then, just to show you those videos, how to insert the lens. So, of course, the lenses have to be full filled with saline solution. So what is also important is the fact that you have to use a preserve-free saline solution, so no conservatives inside the liquid. That is very important. So because you will notice, you will have a global staining if the patient is fulfilling the lens with a saline solution who have preservatives in it. Doing that, you will have a diffuse staining in all the cornea. So if one day you have a patient that you have fitted with a scleral lens, everything was okay, but if you see him after 1 month and during the check you see, wow, a diffused staining when you remove the lens, well, you have the answer. The problem is not your fitting. The problem is the fact that your patient is using a solution who has preservatives in it. So you need to insist on the fact that it has to be used only with a preservatives-free saline solution. Of course, no soaking solution inside. I say that because I have seen some patient who has done that. So of course, that is forbidden because that will cause, once again, diffused staining. So when the lens is in fulfilled, the problem is, of course, there is an excess of weight. That is the reason why you need a small support, like here, this typical scleral suction holder. So in order to stabilize the lens, and then the lens has to be inserted like that. So most of the time it is not a problem when the patient has succeeded once. So here you see the interest of the ring. So for some patient who cannot use the suction holder just because I have seen some patients, they just have one finger. They have lost the other fingers. I mean, that happens. And so that can be useful. So we have manufactured that. So for some patients. So that works for sclerals and also for some hybrid lenses. So it's the same. It is inserted full field. And also sometimes I have seen, we have seen patients who has lost their arms. that happens. So they need to have someone who open the lids, and they have to bend like that. So some small tricks like that can help and can solve the fitting. Okay, and once again, that works. Okay, so that's how to insert the lens. Now how to remove the lens. So you need to use another suction holder. Don't use the previous suction holder, the large one. It is easier with this small suction holder. Oh, sorry. It is easier with the small suction holder. So after washing hands, the patient uses this suction holder, and normally the remove is easy most of the time. Okay. Okay. So before to see the use of iAdapt in order to help you, do you have any further question on the parameters of the scleral lens, on how to start the fitting?
There's a question from one of the colleagues that he's in Mashhad at the east part of Iran. He asked about the how you realize how much you should change the CL, sagittal or S parameter according to the fluorescein pattern.
Yeah.
I believe that he means how much you can realize 1 step, 2 step, or 3, or something like
sure.
that.
Clear. Yes, understood. I propose you that I will answer a bit later, because I will show you with the use of iAdapt, because the iAdapt is available in order to help you to answer to this need, because that I will show you later, but everything is online, and normally that will answer to you. Okay.
Okay.
Do you need to do a pause now before I speak about the special cases and I show how to adjust everything?
I believe that you continue.
Okay.
And I'll ask you when you are speaking, and may interrupt you later.
Okay, that's fine. So normally, to adjust your scleral lens, normally, Ibrahim, I think we gave you this type of paper sheet that you can fulfill. Ibrahim, do you have that normally? I think so. Ibrahim, do you have that, or this paper that you can give to all the practitioners? If it's not the case, we will be able to give it to you.
Yes, it is available.
Yeah. Yes, available. Okay. So this technical support is important. So normally you fulfill it with all the parameters. So that means you insert the scleral lens, and then you will specify your observation. Then you can send to TGT in order to have the technical support. So for example, here, if you have a patient, you have inserted a lens, and you can see that you have here a small touch at 3 o'clock, 3 and 9 o'clock. So you just specify with this technical paper sheet, so where is your problem, just with drawing. And you can do some specification, so we can see here on the picture that there is a poor wettability. You have a compression at 3 and 9 o'clock. You have to specify the parameters of the lens that you have inserted. What is also important is that you specify the clearance evaluation and please specify after how much time you have done this observation, because as I told you earlier, that affect the clearance between the time you insert the lens and after 1 hour. So here we have an excess of clearance because after 1 hour we still have 300 microns. And as I told you, the final goal is to have around 150 microns or 200 microns, but not more. So when you do that, this is the easiest way. You fulfill this paper sheet and you send to DGT in order to that we do all the change in order to help you. So in that case, we will change the lens we will change the lens and we will manufacture a new lens taking in account this excess of clearance and in order to avoid this compression. You can have also another case where, for example, here you have inserted an AKS toric and you have this picture where you have this touch at the limbus. So once again, the good way to start is to look at the results you have at the slit lamp. You have this touch on near the limbus, so you just have to draw that, but you have also to specify the stabilization here. So stabilization is at 160 degrees, like it has been drawn here. You specify the clearance and the over refraction, and then you can send to TGT. Normally, that is a good way to start, because what is important is to identify where are the problems that you need to improve. Just doing that at the start will allow you to have good success. And I like to have good success at the start. But the other option is to do that on your own using the iAdapt software. So this is the link, and this link will allow you to arrive to the iAdapt, which is directly linked to DGT. And with this iAdapt, will allow you to order, to have all the technical advices online, and all your order will arrive directly to DGT, not to LCS directly, but to TGT, and so that is the easiest way. I will show you online an example here. I will show you a bit later online, but for example, you have this patient here that we have seen previously. If you have inserted an AKS toric with those parameters, you have this touch at the limbus, and you have this clearance and this over refraction. So you can, once again, either decide to send this technical paper sheet to TGT in order to leave them to do the technical calculation, or you can identify and connect to the iAdapt online, and then you just have to press the button AKS because you wish to fit a scleral lens AKS. Then you arrive here. I will show you a bit later with playing online, but you arrive here where you will have to specify all the parameters of the lens that you have inserted. You will have then to specify the fitting you observe. And what is interesting is the fact that you have a menu where you have the different option, and the different option is automatically linked with a picture as an example. So finally, you will just have to choose what is the picture that iAdapt is showing you, and which is the type of picture you see with your patient on the slit lamp. So that answer to your previous question, how do we know to adjust the parameters? Well, the answer is it depends of the type of touch you have. So here, if you have a low contact, so that means that you have this type of picture. So you can press that, and I will show you the result. So I just show you online. So I need to, okay, I show you online. Okay, I just do like that. So now I am connected, I am online. So I just do something here, sorry. Okay, so I'm online. So this is, normally if you're online with the iAdapt address I gave you earlier, you will see not best lens because this is a demo version here, but you will see the TGT logo here.
Excuse me, Manuel.
Yes.
We
Yeah.
lost the picture. Can you check?
Ah, you lost the picture.
Yes.
Okay, I just try to find. Ah, yes, I understand. Okay, I understand. Okay. Yeah. Okay, I think you have it now.
Yes, we have.
Yeah, okay. So typically, so what I was showing you is I am here online, okay, but it is a demo iAdapt address. Normally, if you use your own TGT address, you will have the logo of TGT instead of this logo best lens here, which is just for the demo. So if you wish to fit this patient that we saw earlier, you press AKS here. You have to insert the name of the patient, the first name, test 3, the date of birth. Then you have either the possibility to do all the calculation for the first lens here, so that gives you the indication to what type of lens you're going to choose in the trial set. But if you want to solve the case we saw earlier, so the one with the parameters I showed you earlier, so that was, I show you, okay, that was this one. So you can specify change of parameters. So you just specify the parameter of the lens we were inserting. So we had a toric lens. We specify the diameter, that was a 16.5, sorry, 5. That was a sag of 4,300. We had a power of +2. Okay. And then you have observation, so your assessment. What about your observation? Is it done on fitting or after 1 hour of wearing time? So we said 1 hour. After 1 hour, then you have to specify what about the diameter. Is it optimal or not? So you say optimal. And then you say, what about the quality of the fluorescein you see? So you see, as soon as you go in the menu, you have the picture that you can see. So in order to help you, in the center, you have no contact, low contact, moderate contact, strong contact, okay? Well, in the picture, we had no contact at the center. At the cornea, you have low contact, moderate contact, strong contact. Well, we had no contact. At the limbus, that was the reverse. We had a low contact, or not moderate like that, or not strong. So I say low contact, okay? This is what I can see. Then on the S, on the sclera, you have no compression, low compression like that, moderate compression, or strong compression. Well, we had no compression. And you can do that at the flattest scale and the steepest scale in the same time, okay? We had another refraction of plus 0.25. And when you do that, you say calculate. Whoa, it says error. Please enter valid stabilization axis. Oh, yes, I have. So this is typically, we have forgotten the stabilization axis. This is what I told you earlier. And you noticed what was the stabilization axis. It was 0. So, okay. So once again, if you have forgotten something, it will help you. Now I say calculate, and you can see it will automatically calculate the right length to order. And you will see here that it has given the L index plus 2. That's answer to your questions, because it was a low contact, so it ordered L plus 2. If finally you say, oh, no, I made something wrong, it is, I had moderate contact. So say calculate once again and say, oh, plus 4. Okay. If it was a strong contact, plus 6. Okay. So you can also play with the iAdapt in order to have the type of the answer to the question you can have in mind. How much do I have to change in order to, when I have a contact somewhere? If, for example, I had a contact also here, not at the limbus, but in the paracentral area, say calculate. So you see, sorry, here, moderate, calculate. Oh, it does not want like that. Low contact. Okay. So that will change the C here. Okay. Plus 2. Okay. So when you do that, you then have 3 possibilities. You can just save. So when you do that, that just save the calculation, that do not send the order. You can copy the parameters, and when you do that, the interest is the fact that you just click one time. It says, okay, the calculation have been copied. So when you, if you have your own oops, sorry, just see like that. If you have, yes, you cannot see like that the screen. Your own software, you can copy the parameters in your own software. And then with this sign arrow base, if you press that, I press, there is a message saying, do you confirm this order to, well, here it's client test because this is a demo, but it will say transfer to TGT. Do you confirm? I say yes. And then I will receive an email. You will receive on your own email a confirmation order, and TGT will receive the order directly. Okay? So once again, it has been done in order to help you to solve the different needs. So I advise you to play with it and to use it, because this is the easiest way.
Excuse me, Emmanuel. Is it possible we change the toricity of the lens also in the iAdapt, or it's not necessary to change the toricity?
Well, yes, you can change the toricity here. So normally, you just have one dot, it's here. You can change, well, you can increase normally the toricity with changing the parameters here, toric P. So you can change, and you can change with the pinguicula, or you can ask for a higher toricity. Normally, yes, you can do that with different ways, but normally you can change like here on these parameters here. You say 10, for example, here.
Thank you. Thank you.
With pleasure. So I go back to the PowerPoint. Up, okay. And up. I go back to the PowerPoint. Okay. Just 1 second. Okay, that's the one. Yeah. So we saw for this case how to solve it with the iAdapt. So you fulfill what we have done here. You send to the distributor, and you have all those messages, and you receive this email. And typically, this is the email you received with. You have one copy you received and one for the distributor. Another case here, for example, if you have inserted here an EKS toric and you have all those parameters, the stabilization axis is at 10 degrees. You have a clearance at the center of 200 microns after 10 minutes. And you have two problems. You have a compression with a pinguicula here, and you have a touch all around at the L here, and with this over refraction. So you press AKS, you specify all the parameters of the lens that you have inserted. Then you have to choose the right picture that the menu is proposing you. So for example, here you have a strong compression at the limbus and strong contact. You have also changed the design to, and you have changed the design to use a toric design, but with a P. P for pinguicula. So this is what you have in terms of problem here. So you need to have a design allowing you to change with a P. And then you're going to specify the type of compression you have with your pinguicula here. So if you have the pinguicula 1 or pinguicula 2, because you can have in both sides, nasal and temporal. So here we have a pinguicula only at 175 degrees, 190 degrees, sorry. So you just have to precise if you have a low compression or strong compression. So if you press low compression and then you specify the axis 190. If you have no other pinguicula, you don't have to specify. And then that will automatically calculate the specific asymmetrical design with this grade automatically, and with the L value, L plus 6 here. So once again, normally easy, and it is done in order to help you to make it very easy. If you have two pinguicula like that, And with this type of case, so normally this is the type of lens that you're going to order. So you can do on your own if you have those two pinguicula and you know that you need to have a specific design. So AKS ferric P for pinguicula, and so you order with grade 1 and for the pinguicula 1 and grade 1 for the pinguicula 2 with the two different axes. And you have also to take in account the fact that you have an excess of clearance here. It says that you have 500 microns of clearance after 2 hours. This is too much. So you will need to decrease at least 200 microns. So that is the reason why you finish by 4,100 microns. And so you can do that. So this is the explanation of the fitting. So you can do that with sending this technical sheet to TGT, or you can do that with using the iAdapt with, once again, this web address here. Okay. And once again, I advise you to use the web address here. This is much easier. Well, the iAdapt is not only for the scleral. Normally, you can use it for all the type of lenses. You will find the hybrid lens, so you can fit the hybrid lens. You can fit an RGP lens. You can fit the ortho-K lens. The ortho-K is also interesting because with the ortho-K, we will help you in all the fitting. I can show you right now with the software online. So I need once again to change the screen. Okay, yeah. So you have. So I am once again online. So I go home here. So if you wish to fit an ortho-K lens, you just press ortho-K. And what is interesting is, well, you can have the calculation automatically of the ortho-K lens. I go quick on that. So you just have to specify, to specify the right, the parameters of the patient here. Okay, if you have a -4, I go quick on that just to show you. So it calculates automatically the lens that you can order. But what is, I go quick on that because it's just to show you what type of advice online you can have. So when you have received an ortho-K lens and you say, well, I see the patient after 1 week, you have also a menu where you just have to specify what you see. For example, you have to specify what is the topography after 1 week. So is it like that, or like that, or like that, for example? If you say, okay, it's like that, then it says you, what about the corneal fluorescein? Do you have no staining? Or you have a slight staining, you have central staining, peripheral staining. Okay, so you have to then, what about the total diameter? Is it optimal? Or is it like that? Or is it like that? Or is it like that? So once again, I don't insist on this fitting because this is not the subject here, but I invite you to play with the iAdapt because you will have all the information to help you to start. And you just have to follow the different menu that is offered online to you. Okay. I go back to the presentation once again. And okay, I think, anyway, I think it is almost finished. Yeah. Yeah. So you can use the adapt, and so you can fit even the standard RGP lenses like the area. So once again, you specify all the parameters and you can order directly. That is easier, and really I invite you to look at that. And this is it. This is what I wanted to talk about for you today. I hope that it will help you to start with the scleral lens. I'm here to answer to your question. I have not been too technical because I prefer to give you the main lines in order to allow you to start, and then you know that with the use of the trial set and the iAdapt online, normally you will be able to have good success with the fitting.
Thank you very much, Emmanuel.